All right, for this problem we have a normal random variable with mean mu and variance sigma squared. And the question is to find the density of y is equal to e to the x. This is called actually the log normal distribution. If you look this up, this is called the log normal distribution. All right, now there's a formula that we can plug into, but my personal preference is to find the CDF first and then differentiate. So we remind ourselves that the density function for x is 1 over sigma squared root of 2 pi e to the minus x minus mu squared over 2 sigma squared. That's the density function for, and I shouldn't use the phi because that's usually used for standard normal. That's the density function for a normal random variable with mean mu and standard deviation sigma. So if I let y equal e to the x, I want to find the probability that capital Y is less than or equal to y. That is going to be the CDF for capital Y. And then I will differentiate this to figure out the CDF for, find the PDF for y. Okay, so that's the probability that e to the x is less than or equal to y. And then I massage this inequality so that it involves only x. Now the good news is that natural log is an increasing function, and so if I take the natural log of both sides of this inequality, the crocodile stays pointing the same direction. And so that's the chance that capital X is less than or equal to natural log y. In other words, this is the CDF for capital X evaluated at natural log y. So when I take the derivative, the PDF for capital Y will equal, well, let's see, I take the derivative of this, so it'll be the PDF of capital X evaluated at natural log y times the derivative of the inside with respect to y, which will just simply be 1 over y. So to finish off the calculation, I plug natural log y into the PDF for x. So that'll be 1 over, now I have a sigma times square root of 2 pi. Then I've got this extra y in the bottom also. Then I have e to the negative natural log y minus mu squared divided by 2 sigma squared. Now what are the possible values of y here? Let's see, so y is equal to e to the x, so x can be any real number. If I take e to any real number, that number must be positive. So this takes values if y is greater than 0.